One of the main reasons why closures are so powerful is because they allow us to use variables from functions that have already been removed from the execution stack. Now, if you know what an execution context is and how the call stack works, you can skip this lesson. Just keep in mind that to really understand closures, you need to consider that closures allow us to use information from inside of a function that is apparently gone after this function has been removed from the stack. Now let's have a quick look at how the call stack works. During execution, the JavaScript engine needs some way to keep track of all the functions that are being called and executed. And for that, it uses what is known as the execution stack, the call stack, or the control stack, which are the same, as a section inside the memory where to execute these functions, as they are being called by the program. This is usually explained as a stack of books, plates, or whatever. Now, imagine a deep box that you can only open from the top, that you have to fill with books laid flat. Once it's full, the only book you can see is the one on the top, and to access the book at the bottom, you must remove the ones above it first. This is known as the LIFO discipline, which stands for last in, first out. So the one at the top will be the first one to be removed from the stack. Now, following this analogy, each of these books represents an execution context, so a place where each function is being executed. And for every function call, an execution context will be created. So every function has its own private space, let's say. And no matter how big is this function, or how many functions it has nested inside. Then, once the entire function has been executed, this execution context will be removed from the stack. So the book at the top will be removed. Something that may be a little bit confusing is why, when we have nested functions, the execution context of the parent function remains on the stack, while the functions inside are being executed. Well, it's just because that parent function has not finished yet its own execution. Just to put it this way, the execution of a function inside of another function is just a simple instruction, the same as any other one. The only difference with some other instruction is that it will have its own execution context, and that's it. Then, once the child function has finished, its parent function will be able to carry on with the next instructions if that's the case. So, if the next instruction is another function, then another execution context will be created once it's called. The thing is that, during execution, at every single moment, we have only one active execution context, while the others remain inactive, until that function has been executed and deleted. I'll show you what I mean. I'll be using this tool so you can see the call stack in action for two different programs. In the first case, we have a simple sequence of function declarations and function calls. So a function is created and executed, and that's it. Once they are executed, you can see how they are removed from the stack. So even though it does not look like a stack, it is. It's just because it's being filled up with only one function at a time. Now with this next example, we have some nested functions. You can see how function 1 is called, and how executes some code. But it also includes function 2, which includes some more code as well, and a third function, and so on. But as I said, function 1 remains on the stack, and so does function 2, and so on. And that's the point. Their code is executed, but their execution is not finished until the functions they include inside are done. And in this case, we can see how the call stack is being filled up. Now, when function 4 is already executed, it is removed from the stack. And as there's nothing else to be executed inside function 3, it is also removed from the stack, and so on, until the stack is empty in this case, because we had function 1 being executed. Now, the JavaScript engine keeps reading and executes the last function, so it creates a new execution context inside the stack, executes its code, and then it is removed. The thing is that every one of these boxes is an execution context, and inside of each box, two main things are taking place. One is the storage of variables and other functions needed so the JavaScript engine can execute the function, and the second one is the execution of the function they are created for. And here is when we can relate all this to closures. All these variables and information inside of an execution context are also deleted whenever the function is already executed. Now, how closures can manage to use that information? We'll see this in the next lessons. I'll see you in just a minute.